Here we go. Again, give me just a second here. Give me a second here and it'll start up for us. Got to get the document camera warmed up. Again, in about 10-15 seconds, we'll be right in. I'll start number 11 here as soon as it starts up. Here we go. Number 11. Try to do this a little darker here so you can see it, see if it's any easier. So number 11 says we have the cosine of 285 degrees. So we need to find two angles that add up to 285 in the unit circle that we know. This sounds like maybe 240 and 45. I like those. So you can pick whatever ones you want, but I'm taking 240 and 45. Cosine's choosing, so that's going to be cosine of 240 times the cosine of 45 minus, because they're opposites, sine of 240 and sine of 45. Now again, remembering our unit circle, 240, that's the one down here. Cosine, which is the y value, is going to be negative square root of 3 over 2. Cosine of 45 is square root of 2 over 2 minus the sine of 245. Ooh, you know what? That's a full class ticket right there, folks. That's a full class ticket. Cosine is not the y value, but the x value, so that should be negative 1/2 times square root of 2 over 2 minus the sine of it is going to be square root of 3 over 2 negative times square root of 2 over 2. So we get minus the square root of 6 over 4. So minus and negative becomes plus. That's going to be negative square root of a 2 plus the square root of 6 all over 4. And there you go. Now you may have it so that it's square root of 6 minus the square root of 2 all over 4, which that works as well. Okay, let's take a look at number 12. Number 12 says the sine of 15 degrees. So to get to 15 degrees, we could take the sine of 60 minus 45. So Sinbad is choosing sine of 60 cosine of 45 minus sine of 45 cosine of 60. Sine of 60 happens to be the square root of 3 over 2 cosine of 45 square root of 2 over 2 minus sine of 45 square root of 2 over 2 cosine of 60 1/2. So this is the square root of 6 minus the square root of 2 all over 4. And there's your answer. Number 13. Oh, I'm sorry. I don't know if I scooted that up. I got to keep remembering to scoot things up. I apologize. Why don't you guys give yourself another ticket just for being patient with my new video recordings. Here we go. Number 13. 13 says we have the cosine of 5 pi over 12. Now remember, we don't know any pi's over 12. We know like pi over 6. We know pi over 4. We know pi over 3. If you change this to be over 12, we multiply by 2 over 2, which this is 2 pi over 12. Multiply by 3 over 3 gives us 3 pi over 12. Multiply by 4 over 4 gives us 4 pi over 12. Which ones add up to give it 5 pi over 12? These two right here. So I'm going to rewrite this as the cosine of pi over 6 plus pi over 4. So cosine of pi over 6 times the cosine of pi over 4, opposite, minus sine of pi over 6, sine of pi over 4. Cosine of pi over 6, that happens to be the x value, so that's going to be square root of 3 over 2, times square root of 2 over 2, minus sine of pi over 6, 1/2, times square root of 2 over 2. So that gives us square root of 6 minus the square root of 2 all over 4. Now they won't always be the same, but they will look very, very similar. Okay? Have a lot of similar looking things. 14. 14 says the sine of 7 pi over 12. Again, looking up here, which of these add up to be 7 pi over 12? Well, it happens to be pi over 4 and pi over 3. So I'm going to rewrite this as the sine of pi over 4 plus pi over 3. That's going to give us sine pi over 4 cosine pi over 3 plus sine pi over 3 cosine pi over 4. Sine of pi over 4, square root of 2 over 2. Cosine of pi over 3, 1/2, plus sine of pi over 3, square root of 3 over 2. Cosine of pi over 4, 1/2, giving us square root of 2 plus the square root of 6 all over 4. And there's our answer. We're done. Look into number 15. Ooh-hoo-hoo. 15 says graph r equals 5 sine of theta from 0 to 2 pi, and we're doing this, I believe, by hand. It doesn't say to, but I think they want us to because of what they give us. So here we go. Let's take a look. We're going to have theta and r, and notice they already give us a whole bunch of thetas. We're going to see if we can see us a pattern at some point in time. So let's go ahead at least up to pi over 2 and see what we get. So the sine of 0 is 0. 5 times 0 is 0. So over here is my polar graph. So there's my polar graph. And we'll try to, let's see if I can't maybe make a little more enlightening here. We'll go maybe with a blue pen or smaller. I don't know. We'll see what we got here. See what we can do. So my first point is right here at 0, 0. Pi over 6, which is this line about right there. Maybe not quite that sharp, but you know, somewhere in there. I'm going to take pi over 6. Sine of pi over 6 is 1/2. So it's going to be 5 times 1/2. So 5 times 1/2 is 5 halves, or 2.5. So pi over 6, I'm going to come out 1, 2.5. I put a dot, and I'm going to connect those two. So there it is connected, okay? Let's go ahead and take a look at pi over 4. It's sine of pi over 4 squared to 2 over 2, which is 0.707 times 5. It's got to be approximately pretty close. And you can do this with your calculator, but I'm going to say it's pretty close to 3.5. So pi over 4, which is the one right in the middle here, at pi over 4, that's going to be a 3.5-ish. 1, 2, 3.5. It's like right there, so this graph is doing this. Okay, and pi over 3, which pi over 3 is kind of now the one up here. Sine of pi over 3 is the square root of 3 over 2, which is 0.866 times 5, which is going to be a little bit less than 4.5. I'm going to say it's got to be probably around 4.2, 4.3, somewhere in there-ish. You can do it on your calculator again. So 1, 2, 3, 4 point. It's got to be like right in there. So there that part is. Right there. And then at 0, at pi over 2, pi over 2, sine is 1. 1 times 5 is 5. So I'm at 1, 2, 3, 4, 5. So I'm here at the top. And now if you think about it, you're just going to start working your way back down. So in other words, at 2 pi over 3, which is this one over here, you're going to be the exact same spot you were right here. So it's going to be like right there. So it's going to start working our way back down. At pi over 4, I just turned that totally sideways on you guys. Sorry about that. At pi over 4, then it's going to be at the 2 to 3.5-ish. So it's like here. So it's coming to there. And then at 5 pi over 6, it's coming back. Yep, we'll see you later.
Thank you.
2.5, yep. And then we're going to get back to 0. So now we're right there. And then it's just going to go around itself again, because as you go to the negatives here, so now as the y value gets negative, the only difference is going to be 5 times. So when we get down here and we're doing things like 7 pi over 6, it's going to be 5 times negative 1/2, which is a negative 5.5. So that means instead of shooting this way, 2.5, we shoot back this way, 1, 2.5. So it brings us back to here. So we're just going to follow that around one more time. So that actually just goes around one more time, and we are done. Okay, let's go ahead and take a look at 16. So 16, try to do that down here. 16 says we have r equals 4 cosine of theta. Again, we're going to try to see what kind of things we can come up with, a pattern or so, for theta and r. So we have 0, pi over 6, pi over 3, pi over 4, pi over 3, pi over 2. Let's see what we get to first here. And then we'll go, so here, let's get our, so So there's 0, there's 1 ring, 2, my circles are not looking good here, 3, 4, that's better, 5, let's see if that can do it for us. Okay, so plug in 0. Cosine of 0 is 1, 1 times 4 is 4. So at 0, I'm at 4. So that would be the point, 1, 2, 3, 4, right there. That'd be that point. So pi over 6, so if we can get that a little better, there we go. It's going to be cosine, that's going to be square root of 3 over 2, which is 0.866 times 4. That's got to be about probably 3.3, 3.4, somewhere in there-ish. So I'm going to go 1, 2, 3.3, so there that is. At pi over 4, we're square root of 2 over 2, which is 0.707 times 4, which is going to be approximately like 2.8. 1, 2.8. So we're moving in a little bit. So we just kind of keep moving in. The graphs just kind of keep moving in. Pi over 3, it's 1/2. Cosine of pi over 3 is 1/2. 4 times a half is 2. So that's going to give us a point. Let's see, pi over 3 is going to be about right there. So it's going to be a 2, so it's going to be there. So now we're into there. And then at pi over 2, then my cosine x value is 0. 4 times 0 is 0. That brings me right back here to the origin. So I'm right there. So I'm thinking it's going to probably now go like this because the x values, think about it, when you move into the second quadrant, your x values are going to be negative, which that means instead of shooting you this way, they're going to shoot you in the opposite direction. So it's going to be down here, I bet, at 2, and it's going to keep coming around. And then here at 3 pi over 4, it's going to shoot me in the opposite direction, and I bet it's going to be negative 3.3. Oh, that one's not there. That one's here. Okay, so there. Then we're at 3.3, which is there. So this should come to there. Alright, full class to keep. And then we're back to here, and then it's just going to follow itself around again. So there's our number 16. And we're done. Okay, I'm going to stop the video, and I'm going to make another video here in a second. So we're going to go ahead and stop. Again, thanks for your patience, folks. I appreciate it. And we're going to just go ahead and quit that.
Cool. I have to go to work.
Uh-oh.
Mr. Acting, can I get the rest of the test?
No.